All right. So the last thing I need you to show you how to do is how to divide radicals. Okay. Honestly, again, multiplying and dividing is a whole heck of a lot easier than adding and subtracting. Okay. You only have one thing that you need to check before you can divide. If we divide radicals, just like when we multiply, they have to have the same index. Okay, so I can multiply a square root times a square root, a fourth root times a fourth root. But what I cannot do is I cannot multiply a cubed root and a fifth root, or a cubed root and a square root. They have to have the same index. I'm dropping things back here.
I'm sorry.
All right, so as always, there's steps. Step number 1, simplify the coefficients. Okay, simplify the coefficients. Step number 2, simplify the radicans. What's a radican?
Yeah. What's inside?
What's inside the square root?
I put an S on it. Should I not do that?
Radican, you can. It doesn't.
Okay.
Yeah, it's not gonna. It won't hurt anything. I'm switching up the steps because I don't like the steps that I use last semester. It's complicated. All right. Simplify.
Simplify.
Simplify any square roots.
Simplify the square.
Reduce if necessary. Rationalize the denominator. Whoops, if I could spell today. Again, if necessary. You only need 5 steps, so you can cross off 6. I used it as an extra space for step 5. Okay. Rationalize the denominator if necessary. So it looks like it's just a bunch of simplifying. It pretty much is. Anybody still need my steps up?
Yes.
Because she's writing for 2.
Well, it's a good friend.
She is a good friend.
Taste notebook sticks here.
Huh?
Taste notebook sticks here.
No, I had
No,
it because
she
I had
had
to, yeah, so she's lucky. She better thank me that I had.
All right.
You filling out for Harley? But,
Okay. Okay. So here's my 2 examples. So step 1 says simplify the coefficients. What's my coefficient?
The
3 and
3 and the 2. Does 3 over 2 reduce down at all? No. So that's good. So we leave it as a 3 and we leave it as a 2. Okay. Now they want me to simplify my radicans. I've got a 20 over 4. What does 20 over 4 reduce down to? 5 over 1. So this now becomes the square root of 5 over the square root of 1. So we did step 1 and step 2. Simplify any square roots. Is the square root of 5 a perfect square? No. Can't do anything with it. What about the square root of 1? It's 1. The square root of 1 is just 1. Okay, so this is where you need to start getting into the ideas of the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4. Okay, my suggestion to you is to memorize probably up to 12. Okay. So this is technically 1. So this is 2 times 1, which is 2. So my top doesn't change, but my bottom does. Okay? Do you see anything else there that can be reduced? No. 3 over 2 is still in simplest terms. Can't do anything with it. Okay? Rationalize. You only have to rationalize if there is a square root left in the bottom. Do I have a square root left in the bottom?
No.
No. We're done.
Period.
Not necessarily. Sometimes it will come out to just be like 4. It all depends on what numbers they give you.
Oh, so if the top came out to like a bill 4, then it'd be like 2.
So like, yeah, if you ended up with like, I think this is where you're going with it. So like if I had this instead of 3, 4 over 2 reduces down to 2, so your final answer would be 2 square roots of 5.
What if you're in the was 2? How would you like multiply that in? Like,
Because your index is 2.
Oh, I mean not 2, but like if they're the same, right? So if they were like 3. Oh, that's just the square root. Never mind. I mean, not the cube root.
Yeah, it would be the same thing. It's just instead of the square root for your answer, you'd have the cube root.
Wait, so it would only work if you have a cube? I mean, if you have a square?
No. You can only divide if they have the same index. So I can't take a square root and divide by a cubed root. But if I had a cubed root and a cubed root, you would do the same steps. It's just the cubed root instead of the square root.
So with a cubed and a squared, you can't do it at all, or is it just different steps?
You can't do it at all. Cannot be divided. Okay, take a look at this last example. What's my coefficients? 1 and 5. Can they be reduced? No. I'm going to write the 1 there just for now. So 1 and 5. My radicans are 15 and 20. Okay, it's divisible by 5, which means I'm left with 3 and 4. Okay, can I do anything with the square root of 3?
No.
No, it's simplified. Can I do anything with the square root of 4? Yes, it's what? 2. So this is technically 5 times 2, which is 10. Can I reduce any more? No, you've got 1 over 10, and all you have is a square root in the top, so we don't need to rationalize. We're done.
Oh, so 10 is like a coefficient?
Yes,
Miss Em, what did you get the 1 from again?
the 1 and 5 came from here. There's a 1. Remember, if there's no thing there, your coefficient's a 1. Just like if you had x, there's 1 x there.
And the 3 and 4.
And the 3 and 4 come from 15 and 20 are both divisible by 5. And when you divide by 5, it reduces down to 3 over 4. Okay? Good questions. Anybody else? Okay, this glues in on 115. You can also glue in this one on page 116. This is
You said 150?
yes. So, a little bit of history lesson in with your math lesson today. Yay, history!
Boo.
Amazing.
Listen.
Strongly disagree.
I strongly dislike history too, but listen, we'll pretend. Even as a math teacher, I had to take a class in college called the History of Mathematics.
Man, what?
I'm not kidding.
Nobody cares about
That is not a joke.
Mathematics.
Was it terrible?
Awful.
Oh,
Of every class that I ever took, awful.
Is this what you want to do when you grow up?
Yes.
When you were younger, I mean.
I decided in the 8th grade when my 7th grade math teacher, my favorite math teacher in the whole entire world, passed away, that that's what I wanted to do with my life.
Oh, it's like
And
that.
you kept that?
And I
And
kept
about
it from
anything
the
else?
8th grade.
Oh, goodness.
That's
Real
hurt.
good. I just, it's like, it has to be a background story like that. Other than somebody just like, oh, yeah.
Gotta be.
Wait, so.
And then this one, yeah.
All right.
They don't write down their ages. Is that a-
So the last thing I need to do is to teach you how to rationalize the denominator. What in the world does that mean?
I don't even know what response means.
Okay. Rationalizing the denominator means we need to get rid of the square root in the denominator. We're going to get rid of it. What, you don't like rid? You don't like my accent? Okay. So, first we need to understand why. Why in the world can we not just divide by the square root of 5? Why can't I just divide by the square root of 3?
Okay, we're just not doing it.
Okay. Back in the day, yes, this is before Miss Smith's time. I'm not that old. Okay. We didn't have calculators.
Really?
I know. Oh my goodness. Let me see if I can find a piece of paper too, because this will be phenomenal.
So, like, I just don't, I couldn't.
You know me.
I wouldn't.
That's
Oh, we know you are right.
Listen, you know I'm crazy and you love me.
That-
I just don't get how they function without like technology. I think I would like.
Okay. So, back in the day, they didn't have a calculator to just plug in the square root of 3 and give them a lovely decimal.
Are you really-
Instead, they had this.
Oh, no.
Boy, yeah.
So, if they wanted the square root of 2, they'd have to find the square root, and they'd have to find 2, and then they'd have to use this decimal to divide.
Cool.
They had to find the 5th root of 5 and use this decimal to divide. Okay? They did all this by hand.
There was some good ones.
Very difficult to, 1, have to look it up all the time, and 2, dividing by a decimal is a pain in the butt. Okay? So they came up with rationalizing the denominator. When do we do it? We rationalize the denominator whenever there's a radical in the denominator that will not simplify. So you saw when we divided, you can take the square root of 4. You can take the square root of 1. When you can get rid of it, it's fine. The problem is when I leave a square root of 3 in the bottom or a square root of 7, that's a no-no. Okay, so how do we do this? We multiply both the numerator and denominator by a radical that will produce a rational number in the denominator. So, in other words, you want to make a perfect square. So, if I have the square root of 3, I want this to become a perfect square. So what we do is we multiply by the square root of 3, and that gives me the square root of 9. What's the square root of 9?
3.
You've gotten rid of the denominator. And what you do to the bottom, you have to do to the top by the same number. Okay. So it's not going to be quite as difficult as you think. And we've got a whole booklet on it because it's fun.
No, really?
Yes, it's a lot of fun. Okay. Lots and lots and lots of fun.
But I don't believe you.
But you don't believe me? Would I ever lie to you?
Tay is just at home chilling. She got me messed
I'm for
up.
Your glasses cookie bag.
Okay. Remember, multiplying something by some number does not change its value. What can I multiply anything in the world by and it would never change its value?
One.
One.
What's that?
I can add or subtract 0 and it doesn't change it, but when you multiply by 0, you get 0. So We want to multiply the fraction by 1, so we don't change the value of it. Any expression divided by itself is equal to 1. So I can divide the square root of 5 and the square root of 5. That equals 1.
Just one or just two?
Just 1. That's it. If you put 3 in the top and 3 in the bottom, 3 divided by 3 is 1. 120 divided by 120, 1. It only goes in once. So, to get rid of a radical in the denominator, we multiply both the numerator and the denominator by the radical in the denominator. Wow, this sounds very difficult. It's really not that bad. It's really not. I promise. Okay, that glues in at the top of page 117.
I did it wrong.
It don't matter if you put it at the bottom. It's not going to hurt it. It's still on the same page. And then get out your little booklet. 117. Save space for your booklet is basically all I'm saying. I don't care if it's at the top or the bottom. It doesn't matter to me. Just save space to glue your booklet because it's going to go on that same page.
You don't understand. That glue smells magnificent.
My glue's making you what?
It smells magnificent.
Oh.
That's big. I want some glue though.
Mm.
Why have you ate?
No food. I had a big turkey.
That's not in my book. That'd be weird. That's just.
She's really
You need no pizza?
That type of leg was great. Oh no, that pizza is nasty.
What pieces y'all talking about? School pizza?
Yes.
What? People be eating that. Be like, what?
Why they be enjoying it, putting ranch on it and everything.
What's that?
Don't he go to college? He's a what?
She did mine the first time, remember? Oh, you see, nice.
And then I think Kay did it the second
Exactly,
time.
like one time.
Jackie's never made it.
Okay, I didn't watch Taylor. I don't wait
You would never do it.
Shut up. See, one time.
Okay.
You would never do it.
She got to mess up that.
Yeah, he could.
Yeah, Jackie, all kinds of
Whatever.
stuff. Okay. So we are still dividing. So we still need to go through all of our steps. Step 1, simplify the coefficients. Can I simplify the coefficients?
No.
No, you've got 2 over 1. There is no simplifying. Simplify the radicants. No, you only have the square root in the bottom. So we've simplified and simplified. Ain't nothing to do. The last thing that I have a problem with, though, is I've got that square root in the bottom. Okay, so in order to get rid of that square root in the bottom, what square root is in the bottom? What square root is in the bottom? The whole square root. Square root of 3. So you need to multiply the top and the bottom by the square root of 3. So give me a second. I'm trying to cut this booklet for Jackie here.
Okay, so fine.
You know
You're welcome.
Okay. Well, first of all, you're only a sophomore, so.
Okay. So to get rid of that square root in the bottom, we multiply both the top and the bottom by the square root that is in the bottom. That is the only way to get rid of the square root in the bottom. Okay. So now, multiply straight across the top. What do I get when I multiply the numerators? 2 square roots of 3. Remember, to multiply, you multiply the coefficients. So that would be 2 times 1. And then you have nothing to multiply that square root against. So it just goes there, 2 square roots of 3. When I multiply the bottom, I get the square root of 9.
still have that there. Right.
Okay, but I can now simplify the square root of 9, which is 3. So 2 square roots of 3 over 3. Whoop, there it is.
Right?
Oh, you want to listen to some old school?
Yes.
Whoop, there it is. Bring back the
I
80s.
just said play the jerk. Oh my.
Listen, I was denied. I was born in my favorite era. I only got 4 years of it, and I was so tiny I don't remember it.
Well, it's a good thing you're not old, though.
That is a plus. Okay, this one. Can I simplify the coefficients? No, it's just 1 and 1. Can I simplify the radicants? Yes. This becomes the square root of 1 over the square root of 5. Okay, both of these are divisible by 2.
Oh.
2 is divisible by 2, and that gives you 1. 10 is divisible by 2, and that gives you 5. Okay. Are any of these perfect squares yet?
I mean, one
The top one is. Okay, so this can be 1 over the square root of 5. Square root of 1 is just 1. Okay, it is a perfect square. So now I'm still stuck with that square root in the bottom. So I still have to rationalize. So I multiply by the square root of 5 over the square root of 5. When I multiply across the top, that's 1 square root of 5 or just the square root of 5. I don't care. Please understand that when they give you choices on the test, that 1 will not be written there. It'll just be the square root of 5. Okay?
If you don't put it in the answer, is it wrong?
The 1?
Yeah.
No. It does come out to be the square root of 25, which Teron has just said is just 5. You're done.
So like, why do we need to know these things? It's a question I ask myself on the daily. Exactly, that's what my name is. And I'm not gonna be this in my book.
Why not?
Because. No.
Okay. Square root of 2 over the square root of 6. What do we have when we reduce? 1 over 3. Square root of 1 over the square root of 3. Well, the square root of 1 is just 1. Okay, so we had a perfect square we could get rid of. Okay, I now need to get rid of that square root in the bottom. So we multiply the top by the square root of 3 and the bottom by the square root of 3. Multiply across the top. 1 times the square root of 3 is just the square root of 3. And in the bottom, square root of 9, which becomes the square root of 3 over 3. Okay. If you've now realized that when I multiply the square root of 3 times the square root of 3, all it does is cancel out your square roots and keeps the 3, I don't need to see this part of it if you're good going straight to this. Okay.
Well, this one is.
Okay. Uh-oh.
Right.
Now I gave you some coefficients. Uh-oh. Okay. Can I simplify my coefficients?
No.
4 and 3. No. Nothing goes into 4 that also goes into 3. What about my radicants?
No.
No. Uh-oh.
Please tell me that's it.
Okay. We still have to rationalize. However, I don't have to multiply by 3 square roots of 2. I only have to multiply by the square root of 2. So,
Wait, why?
watch,
Yeah.
because all I'm trying to get rid of is this. Okay? That's all I'm trying to get rid of. So we're going to multiply by the square root of 2 and the square root of 2. Okay, so watch what happens. When I multiply across the top, my coefficients are 4 and 1. So that gives me 4. Square roots of 3 times 2, which is 6. In the bottom, 3 times 1 is 3, and the square root of 4. Okay, now you could have multiplied by 3 square roots of 2, but all that's going to do is cause you problems at the end because you're going to have to reduce at the end. Okay, you don't want to do that to yourself. Okay, so that's why we did not multiply by 3. The square root of 2,
Yeah.
because that's what's in the bottom. That's what you're trying to get rid of. You want to multiply the top and the bottom by what you're trying to get rid of. Because I want the bottom to become a perfect square,
Oh, yeah.
so I can get rid of it. Okay, so now 4 square roots of 6. Can I reduce the square root of 6?
Yes.
No.
No.
Oh, no.
6 just breaks down into 3 and 2. There's nothing I can circle. Okay,
Do 4.
I can do 4 with what? It's not the square root of 4.
Oh.
It's just 4. Don't let that confuse you. So 4 square roots of 6 over, this is 3 times, what's the square root of 4?
That's what I'm
You just
talking about.
said.
I just
Oh.
I was on the top still, friend.
Oh.
That's why I was like, what? That's not the square root. What are you talking about?
I thought you was talking about the.
No, you're good. Sorry, I was still on the top. That's okay. So the bottom technically becomes 3 times 2 because the square root of 4 is 2, which leaves me with 6. Okay, so we got rid of the square root in the bottom. But I've now just caused myself one more problem.
What?
The coefficient.
4 over 6 reduces down to what?
2/3.
2/3. So this is technically 2 square roots of 6 over 3. Now listen.
Wait, how did you?
You said you want the bottom of the divided by
4 and 6 are both divisible by 2. So we divide this by 2 and we divide this by 2.
I get it.
Just like you divided the coefficients at the beginning to see if you could knock them down.
You said that you want the bottom to be a perfect square, but or you just want it to be a whole number.
3 is an actual number though. It's not under the square root.
That's what you. That's
So
what
we,
your goal is.
right, our goal is to get it,
Add it.
have a perfect square so it becomes a whole number so you're done with the square roots in the bottom.
Can I just say whole number?
Absolutely. That's perfectly fine. If that makes more sense to you, Jackie,
Oh, yeah.
rock it out.
It does.
Questions?
You need
So much help.
so much. I don't.
What is
Not
wrong
she.
with me? Okay, I
Listen.
just make a lot of noise.
Don't worry,
I
honey.
know six.
I need a lot of help too.
We all do. I'm pretty sure.
We all need some
And
help.
then you just say.
Okay,
You need more than me.
what reduces?
Okay, whatever. 7. Okay.
What reduces? 15 and 10.
You said 5.
I know he said 5. I was ignoring the fact that he said 5. So 2 and 5 don't reduce, but 15 and 10 do. 3 and 2. Good. Both of these are divisible by 5. So that leaves me with 3 and 2.
Does it matter what you how you call that?
Does it
Like
matter what?
if they share 2 factors, whatever, does it matter what you call that? Like instead of doing divided by 5, you do something else. I mean, not with those numbers, but you know what I'm talking
You
about?
always want to get it into lowest form, so you want to divide by the biggest number you can.
But
So,
you
like, if
don't,
you
you're
had,
gonna be
like, if you had like 8 and 4, the square root of 8 and the square root of 4.
Yeah.
And that reduces to 4 over 1. You don't want to divide it by 2 and make it 4/2. You want it as low as you can get it.
Would it be wrong? Oh, but you would still have to keep multiplying. I mean,
Yes. So you can divide by 2, but then if you can divide by another 2 to reduce it some more, you got to keep going. Okay, so now what square root's in the bottom? 2. So that's what I multiply by. The square root of 2 over the square root of 2. So my top becomes 2 times 1, which is 2. 3 times 2, which is the square root of 6. In the bottom, we've got 5 times 1, which is 5 square roots of 4. Okay, well, the square root of 4 becomes 2. So this is 2 square roots of 6 over 10. Oh, wait. Oh, 2 over 10 reduces down to 1 over 5. So your final answer then is the square root of 6 over 5. Dun, 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 dun. Only one more to go.
And then what are we doing?
And then you're going to work on some IXL. I hate IXL.
I hate L5.
You said what?
I hate L5.
No, L5. No, L4.
She says, I hate L5.
I hate
L4 is easy.
L4 is
L5. L5 was
L4.
You didn't help your child.
Okay, last one. What reduces? 16 and 12. So 3 and 5 can't reduce, but 16 over 12 becomes 4 over 3. Ooh, well, that's nice.
Hold up, wait. What was they divided by?
Both of these are divisible by 4. You're gone. Both of these were divisible by 4. Okay. Before we mess with the top, though, and multiply, is there anything else I can do to this?
You can put it on second.
The square root of 4 is 2. So this is technically 6 over 5 square roots of 3. Now listen, if you wouldn't have done that right away, it would have still taken care of itself at the end. So if you forgot that step, I'll do it on the board over here without that, so you can see both ways. It'll still come out to be the right answer. So what do I need to multiply to rationalize the denominator? The square root of 3. So I multiply the top by the square root of 3 and the bottom by the square root of 3. I get 6 square roots of 3 over 5 square roots of 9. Good. Square root of 9 is actually 3, so 6 square roots of 3 over 15. Can I reduce any more? Yes.
Yeah.
By 3.
By 3.
Good. These are both divisible by 3. So this actually becomes 2 square roots of 3 over 5.
Was that 15?
Yes.
Can you do it the other way?
Yes.
On the board.
Okay. So if you would like to write this way as well, you can. But let me show you what would happen if you wouldn't have reduced that square root of 4 right away. Okay. So I still multiply by the square root of 3 over the square root of 3. So this then becomes 3 square roots of 12 over 5 square roots of 9. Okay, so far so good. Square root of 9 is still 3. So this is still 3 square roots of 12 over 15.
Oh, I see.
3 and 15 reduce to 1 over 5. Square root of 12 reduces. 12 breaks down into 2 and 6, which breaks down into 2 and 3, which breaks down into 3 and 1. I can group in 2s So that becomes 2 square roots of 3 over 5.
I thought it was gonna be like the same number as we make 12. That's why.
Yeah. So the only thing is, if you don't simplify here, it's bigger simplification when you get here, okay?
I have a question about this one.
Yes.
The one that we just did. This is square root.
I don't know.
Can we reduce that again?
Only if it reduces. But that's the square root of 6. So if you go to break down 6, you only have 2 and 3 and 3 and 1, so there's nothing to group. So it just groups one. Yeah, but if that would have come out to be like, the square root of 20, yes, because you would have been able to pull 2 out. So it all depends on whether it can actually be simplified or not. Questions?
Can Lala give me my slide back?
No.
That's my question.
Lola, so your slide?